this circuit, this simple attenuator circuit, we have seen how we go about simulating in Ngspice. In this session, we will introduce one more component. We will see how we invoke models, subcircuits, and refactor the .cir file into subcircuits netlist and .cir file. We will now modify this circuit slightly in this fashion. I will now introduce a diode in series, and this will become a half-wave rectifier circuit. I will replace the DC source with an AC source, and let's say AC source of 50 Hz, and we will call this one as diode D1. So this is a half-wave rectifier circuit, and let us see how we go about simulating this circuit. How do we incorporate this diode and a model for the diode, and try to understand the process of refactoring the .cir file. Let us now build the circuit file for this half-wave rectifier circuit that we have drawn here. So as before, I have here the text editor, gedit, and I have opened example02.cir, ex02.cir. On my left hand side, I have a terminal window open, and it is in the work directory. So after we write the .cir file, we will execute it in Ngspice. So as before, the first line will be a title line, so I will call that half-wave rectifier. Then the netlist. So V1 is an AC source. It is between node A and 0, and I am going to give a sine wave source which is having 0 offset, 100 volts peak. Generally, when they use 100 volts AC, it implies RMS, but I am going to use here as 100 volts peak. Then 50 Hz as the frequency of the sine wave, 0 delay and 0 decay. Next, diode D1. So diode D1 is between nodes A and C. Here polarity is important. A is anode side and C is cathode side. And let us say we give the value as some model called D model. That's a variable. We'll later define what the D model is. R1 is between node C and B, 10 ohms. R2 is between B and 0, 10 ohms. So now the netlist is defined. Let us define the model for the diode. We need to define the model for this diode. Dot model, D model. So this is the D model that I am which I am modeling here, the same name, and we will model it as a diode. And within brackets, there can be various parameters of the diodes, physics parameters of the diodes that can be included, but right now I am leaving it blank, which implies that I am using a default model of the diode. Next, control commands. What Ngspice should do on this netlist. So between the dot control and dot NC statement, I have a tran command, so transient analysis. Let the step value be 1 microsecond, end value be 40 milliseconds. Because this is a sine wave of 50 Hz, which means 20 millisecond period, we will display for 2 periods. And use initial conditions plot, then afterwards we would like to plot, let us say VA and VB, can plot any node and any branch current, and then dot end C, ending the control statements. So now our .cir file is ready. It is ready to be simulated. Let us save that, and after saving, let us go into the terminal window. We are in the proper folder. Let me use ls. Look at the directory. You see that there is ex02.cir which we just created. So let us run that. Ngspice ex02.cir. So you see that it runs through, the control commands are executed, the transient analysis is performed, and it plots the waveform VA and VB. So if I expand this, you will see that VA, the red colored, the source voltage waveform V1, it is having 100 volts peak, 50 Hertz, 10 milliseconds. The half period, full period is 20 milliseconds here. And the blue waveform is VB, the rectified, half-wave rectified waveform, and VB is also attenuated by 50% because you have R1, R2 equal. So in this way you can see the waveforms at various points in the circuit. If you want to look at what is there in the listing, you can see that this is what we have actually uploaded into the Ngspice workspace. You can also try plot all to plot all the currents and voltages. So this will actually plot all the currents and voltages, B, node B, node A, node C, and the branch current. But this is the branch current which is going negative here, which indicates that the current is flowing out of the positive terminal of the source. Note that in the .cir file we have the netlist first, then the model, and then the control commands. It is not necessary that they should be in this sequence. You can also start with placing the control commands first, and then the netlist, then the model. This also will work. You can execute this Ngspice, and then you will see the same results coming up. Or you could place the control commands like before, and only the tran part I am going to remove, and I will have one more comment line. I will say analysis, transient analysis, and here we can place the tran command. But because the tran command is out of the .control.nc statements, you have to put a dot there to indicate to Ngspice that it is an Ngspice control command. And here in the control command can be other control statements which do the plotting statements and few other things which I will tell later. So here you have to indicate that you need to run this you have to run this netlist once it enters the Ngspice workspace. So this is another way where people use to make the .cir file in this fashion, where the analysis is indicated first. then the netlist model, and then the control commands. So this also I can save and execute that. You will get the same results. This is the example2.cir file. This is ex02.cir. We will now dissect this file and refactor it in such a way that leads to good simulation practices. Now this file, if you see, it is containing the header part with the title, analysis, comment lines, and the analysis that you want to perform, followed by the netlist in the model, and followed by control commands. So this netlist portion, let us decouple it from the .cir file and push it to another file. And let us call that as ex02.net. So the netlist file is called ex02.net file, and let us push it there. Now the .cir file should have information on where to take the netlist from. So we need to include this file name here. So let us use a .include statement. Ngspice's .include command will be useful here. So .include ex02.net. So now the .cir file has this include statement which whereby it knows where to take the netlist from. So in this netlist, it is composed of two parts. There is the actual netlist, which gives you the interconnections between the various components. And there is another part, the model part. There may be several models, but in this example, there is only one model. And the models can be pushed into another file. So let us mark this model and let us push it into another file called ex02.sub. This extension .sub is optional. You can have it as .sub or .lib or any other extension, but doesn't matter. But .sub is very descriptive because it describes sub-circuits. So let us push this model part into this sub-circuit file. And this model has to be accessed by the netlist. Therefore, let us have a .include here, including ex02.sub. So this would be the entire refactored .cir file. Let us push this control commands up, and this portion is the actual .cir file, which in turn calls the netlist file, which in turn calls the subcircuit.sub file, which contains the models of the components used in the netlist. So let us refactor the .cir file that we have seen into these three files and rerun the simulation. Now let us look at this ex02.cir, which is now refactored. See here that I have made one change. I have removed the netlist and I put a .include ex02.net. If I go to the work folder, now if I go into ex02.net, it looks like this. You have the title comment line, then the netlist that we had written earlier. Now there is an include ex02.sub, which contains the model file. So if you go into the ex02.sub, it contains the model file. This is a good practice because there will be, in a big circuit, there will be several models, several sub-circuits which you can put in one file and keep it decoupled, and whenever you edit that file, that will have an effect on the overall circuit. So now this circuit file, let us execute in Ngspice. So I will go into the terminal and list. So you see that you have these 3 refactored files for the half wave circuit. Now execute ngspice. Ngspice, and you are calling ex02.cir. The entry point to ngspice is always a .cir file. So you execute it and you will get the same result. If you are interested, you can see the listing. What has been uploaded is exactly the same, and you see that the model comes in the picture, which was included in the netlist, and the netlist itself is included, and this is the analysis that we have put in the .cir file. So in future, all our circuit simulation will contain 3 parts. One file, which is the .cir file, which is the main file which will enter Ngspice, and within it, it will call the .net file or the netlist file, and within the netlist file will call the .sub file, which contains all the models of the components used in the netlist. So in this way, if there is any modification in the netlist, we change only the netlist alone and execute the CIR file again. This is a better simulation practice, and we will adopt this throughout this course. Before closing this session, there is one more point that I would like to make, one more small modification to the .cir file control commands. Let's say when you plot VA, VB, we see the plot window coming up, and you see the background as black. It is better to have the background as white so that when you are documenting, it is better to have a white background for documenting purposes, and also for enabling less ink to be used while printing. So therefore, I will make the following modifications to the control commands in the .cir file. I will add 2 commands. So I will add set color 0 equal to white, which means that set background as white. Background is color 0. I'm setting it as white. And color 1, foreground, 1 is foreground, as black, setting the foreground as black. So now let us save this and rerun. Let me exit, clean up the window, ngspice ex02.cir. So now you see you will get the plots on a white background. This can be easily put into documentation and also can be printed with little wastage of ink. So from now on, setting the background as white and setting foreground as black will be a standard control statement, which will be in our control commands list in all the future simulations too.